Hi, my name is Madison Griffin, and I'm a graduate student at the Virginia Institute of Marine Science. I'm an environmental statistician with a focus on fisheries science. That means that I work with fisheries data to answer questions about the state of the population and how to keep it sustainable. Specifically, I work with the natural oyster reef population in Virginia's Chesapeake Bay. I'm studying how resilient oyster reef populations have been to climate change over time. And this is really important because oysters provide a lot of ecosystem services, including keeping the water clean and providing a livelihood for oyster watermen. So, to answer questions about resiliency and responses to climate change, we need scientists to sample oysters and keep that data for others to use. Luckily, VIMS and the Virginia Marine Resource Commission have been surveying the shell size and abundance of oysters for over 30 years. And in this lesson, your students can see what it's like to be a fisheries scientist. That's why I made my lesson plan titled Histograms on the Half Shell. This lesson is intended for 7th grade learners and can be used in a math or science classroom. Students will learn about survey design and how to represent numerical data using histograms by mimicking the Virginia Oyster Stock Assessment survey. They will learn the anatomy of a histogram, and by the end, they should be able to differentiate between histograms and bar charts. In this activity, beans represent oysters and hair clips represent the patenton, a hydraulic machine used to sample oysters, as shown here in this video. It looks a lot like the claw in a toy machine. For this activity, the class will split into 6 groups, each working with a different year of data. Each bag is made up of a different amounts and kinds of beans to represent oysters of different sizes. The makeup of each bag is shown here. I recommend creating these bags in advance, but you can reuse them as many times as you need. To conduct the survey, each group should use their hair clip to collect 2 samples of beans from their population, or the bag. They should set their sample aside on a paper plate, and then groups should divide and conquer to measure each bean and record their lengths on their data sheet. Students will organize their data into 2-millimeter wide bins, and the lecture PowerPoint will walk through this in more detail, but in short, oysters on the bin boundary belong in the left bin boundary or the lower bound. This is very important to emphasize so that binning is consistent. Then, as a group, students should total their frequencies, and the numbers in the total frequency column will be used to create their histograms. Each group should draw their histogram on a large graphing sheet, being sure to include a descriptive title and some descriptive observations underneath the x-axis. I also recommend making blank graphs in advance for the students so that the axes don't take up class time. Lastly, each group should hang up their histogram in chronological order so that they can infer trends over time about the oyster population. Histograms will vary based on the sample, but they should see that oysters in 2022 tend to be bigger than the oysters sampled in 2006. This is optional, but you could have students brainstorm what factors could have contributed to this trend, and there are some answers in the lecture PowerPoint. Thanks for checking out my lesson, and I hope you and your students enjoy it.